Hi everyone, I'm Irene Japan, your MC for this session. Languages carry culture, identity, and history, but many local languages risk being left behind in the digital age. What if technology could help preserve them, making them searchable, accessible, and alive online? That's the mission of our speaker, Monofal Musafar, an NLP enthusiast and postgraduate researcher from Yogyakarta, Indonesia. He combines Python tools like Spacy, NLTK, and Transformers with open source collaboration to build bilingual digital dictionaries for Indonesia's local languages. Please join me in welcoming Monofal Musaffar with his talk, Building Digital Dictionaries for Local Languages in Indonesia with Python NLP.
Good night, everyone. Thank you for being here. My name is Muhammad Naufal Safar, and today I want to talk about something I'm very passionate about: the intersection of technology and cultural participation. Specifically, we'll explore how we can use the Python and natural language processing to building digital dictionary for the local language of Indonesia. Indonesia is a country of incredible linguistic diversity with over 1,700 living language, but many these are under-resourced, meaning they lack digital tools like spell checkers, translation apps, or even simple online dictionary. This digital gap puts them outreach. The project I presented today based on this collab notebook is a proof of concept. It show a powerful automate method to create a foundational bilingual dictionary using Javanese and Indonesia as our example. Live TV. The next, the goal from parallel text to dictionary. In the left side, a box leverage Japanese sentence with example suge and the right side, a box labeled to Indonesia sentences with example selamat pagi, and arrow connected then labeled Python and Magic, and the last bottom a box labeled bilingual dictionary showing NG to pagi. And so So what is the core idea is simple. If we have a collection of text, the perfect translation of each other, what we call a variable corpus, can we teach a computer to figure out which word correspond to each other? For example, if the model sees Sunggi Engine in Selamat Pagi hundreds of times and also sees Sunggi Xia in Selamat Siang, it will start to infer a pattern. If we learn the sugar like means selamat and NG likes mean pagi, our goal is to automate this process. We feed the machine hundred of thousand parent sentences it producer and word of word dictionary to entire process will we discuss can be broken down into six main steps, which follow in notebook. Ah, in the simple numbers, number one is install necessary library, and number two data preparation, create our parallel corpus, and number three pre-processing clean to text data, or alignment to core NLP text, and number five dictionary creation is extract the translation, and the last point in the application is a building simple translation. Uh, Here's uh Okay. Here the roadmap of for our journey. First, we set up our environment by installing Python library like an LTK and Pandas. Next, we prepare our data. In the case, the 100 Japanese sentences and their initial translation. They come to crucial step of processing, where we clean the text to make easy for the computer to understand. After that, we get to heart of the project, word alignment, where the model learns the transition probability. Finally, we use the probability to build our dictionary and create a simple function to test our results. It's a logical flow from the raw data usable to. First things, data is king. For this demonstration, we create a small dataset to 100 parallel sentences between Japanese and Indonesian directly. In the code in a real world project, this will be the most challenging part, finding a large, high quality parallel corpus. Once we have the data, we can not just feed it into model, we need to clean up this the processing. As you can see in the function our notebook, we propose a few key action. Number one in lower lower sorry and number one is lowercase everything so that aku are treated as the same word. And number two, remote punctuation and number is this don't help in transitive word and just a noise. And number three, tokenize is this is a fancy word for splitting a sentence into a list of individual words. So uh, this is like PA cabaret become clean list PA and cabaret. This is clean. Tokenized format is exactly what our alignment model need. Next, the magical statistical word alignment. Now, for the most exciting part, how does the machine actually learn the transition? We used a classical statistical algorithm scale EBM model 1. You don't need understand of the math, but initiation behind this vaccination. Imagine we have our two clean sentence, aku arep mang and saya mau and makan. In number one, initialization is the model start with the zero knowledge. It assumes that any Japanese word can translated to any Indonesian word with a equal tiny properly. So mang could mean saya mau or makan with equal chance. And number two is expectation maximization. EM is then in begin interactive learning process. In our notebook, this was for the loop for loop that run for 10 iteration. For each iteration, number one step is it look all the sentence where and calculate the expected count. In ask give my card probability. How likely is that mangan translate itu makan is sentence? And number two M step based on this count is update is probably if consistently see makan and makan in the same sentences part the probability makan will increase while probability from other point will decrease. After several iterations, the model converges and we are left in a table of strong translation probably between words. After the model is trained, What do we get? We can hook the table of probability to create our dictionary. We simply iterate through every unique Japanese word from our vocabulary and find the Indonesian word that has the high transition probability, and he the results this table generated directly for our script is our Vanilla dictionary. And you can see it did fantastic job of many words collected mapped aku to saya, manga to makan, and omaku to rumah. But it's not perfect, which also an important lesson. Note how it map pie to kabarmu. This is because of pars pie kabar, but almost always bawi apa kabarmu. So the model linking the most unique words together, this show a limitation of the simple statistical model. It doesn't under grammar, just on occurrence. A dictionary is not very useful. We can use it. So the final step, our notebook, was to create a simple translation function. This is a simple application. Uh, this function take a Japanese sentence, tokenize it, look up each word our newly created dictionary, and stitch the result back to together. As you can see from the test case, it worked quite well for sentences where the word or the similar aku marip mang correctly become saya mau makan. This demonstrates that our automated process from raw text to a functional translation is a success. In conclusion, we have walked through a complete pipeline for automatically generate to bilingual dictionary. We started a parallel sentence, cleaned them, used statistical model to learn from alignment and produce a dictionary. Then we could use the real application. This approach is powerful because it can be applied to any language pair as long as parallel text exists. It's a scalable and effective way to begin creating to vital digital resource for underrepresented language. Of course, this is just a proof of concept. To building truly robust dictionary, we will need too much more data and could explore for active model, but is a first step. This project what is possible with a big amount of data and power of Python. Thank you so much for my material about sorry, and once again, thank you so much for my material about building a dictionary for local language Indonesia with Python uh, for Phil Ladies Conference. Thank you so much, and I see you in Indonesia for Yogyakarta. I'm from the community of P Jogja. Thank you so much.
What an insightful session. Mustafa just showed us how Python NLP can do more than process text. It can help preserve linguistic diversity and give local languages a digital future. The big takeaway: technology and open source collaboration can turn documentation into preservation, ensuring voices are not lost but amplified. Thank you, Monofile, for inspiring us with this vision. And thank you all for being part of PyLadiesCon 2025.